What if the universe itself is conscious, not just as a collection of stars and galaxies, but as a vast, thinking entity, a cosmic mind woven into the fabric of reality itself? This isn't science fiction. It's one of the most provocative questions at the frontier of science, where quantum mechanics, consciousness studies, and cosmology collide in ways that challenge everything we think we know. For centuries, we've seen the universe as a cold, mechanical place, governed by unfeeling laws. But what if there's more? What if the cosmos is alive with a kind of intelligence we're only beginning to glimpse? Today, we're diving into the enigmatic world of quantum consciousness and cosmic structures, a realm where particles communicate instantaneously across vast distances, where black holes might encode information like cosmic hard drives, and where the very fabric of spacetime could be threaded with something resembling thought. These aren't just wild speculations. They're revolutionary ideas emerging from the edges of physics, philosophy, and metaphysics, each one offering a tantalizing peek behind the curtain of reality. Some of the brightest minds in science are now asking, could consciousness be a fundamental feature of the universe, as basic as gravity or light? And if so, what does that mean for us, for our place in the grand scheme of things? Over the course of this journey, we'll explore 28 groundbreaking theories that turn our understanding of existence inside out. From the holographic principle to the idea that every atom might carry a whisper of awareness, these concepts don't just reshape science, they invite us to rethink what it means to be alive in a universe that might be far stranger and far more interconnected than we ever imagined. So if you've ever stared at the night sky and felt a flicker of wonder, if you've ever questioned whether there's more to reality than meets the eye, then you're already part of this exploration. Let's begin. Imagine two particles separated by billions of light years, instantly mirroring each other's states, no signal passing between them, no delay, just perfect synchronization. This is quantum entanglement, one of the most baffling phenomena in physics. But what if it's more than just a curious quirk of the quantum world? Some scientists speculate that entangled particles might be the building blocks of a cosmic neural network, threads of communication weaving through the universe, connecting distant corners of reality like synapses in a vast thinking brain. Take the delayed choice quantum eraser experiment, where particles seem to retroactively change their behavior based on future observations. It's as if they possess a kind of foresight, as though the universe itself is processing information outside our linear flow of time. If that's true, could entanglement be the mechanism by which a universal consciousness thinks? Picture galaxies, stars, even black holes linked by an invisible web of instantaneous communication, exchanging data in ways that defy our classical understanding of space and distance. And if entangled particles form the neurons of this cosmic mind, what role might black holes play? These enigmatic objects, with their unfathomable gravity and ability to warp spacetime, could act like supermassive processors, absorbing, transforming, and perhaps even transmitting information across the fabric of reality. Some theories suggest that black holes don't destroy information but encode it in ways we're only beginning to decipher. If consciousness is woven into the universe's structure, black holes might be its most powerful hubs, crunching data on scales we can barely imagine. This idea blurs the line between physics and metaphysics, challenging us to reconsider whether the universe is merely a cold machine or something far more mysterious, alive with a form of intelligence we're only starting to perceive. If entanglement is the language of cosmic thought, then black holes could be the punctuation marks, shaping the flow of universal awareness in ways we've yet to understand. Black holes, cosmic giants with gravity so strong not even light can escape, might hold the key to understanding a universe that thinks. Picture this: just as synapses in our brains transmit electrical signals, black holes could be cosmic connectors, firing bursts of information across the universe through Hawking radiation. This faint glow, predicted by Stephen Hawking, isn't just random energy. Some theorists propose it could carry encoded data, like a cosmic Morse code, broadcasting the history of everything that ever fell into the black hole's depths. It's as if these gravitational behemoths aren't just destroyers but librarians, meticulously preserving and transmitting stories written in the language of quantum particles. The holographic principle takes this even further. Imagine the entire three-dimensional universe we experience is actually a two-dimensional projection, like a hologram, with black holes serving as the projectors. Their event horizons, the points of no return, could be vast screens where information is stored, pixel by pixel, in ways that defy classical physics. This isn't just about storage, though. If black holes process information like a brain processes thoughts, could their singularities, those infinitely dense cores, be the universe's thinking centers? Places where raw data becomes meaning, where quantum fluctuations translate into cosmic decisions. Now, consider the eerie parallels between black hole thermodynamics and the way our own brains work. Both systems thrive on chaos and order, with entropy playing a starring role. In a brain, neurons fire in patterns that balance randomness and structure, creating consciousness. In a black hole, particles swirl in a dance of entropy and energy, potentially giving rise to something far grander. Could the universe be using black holes as neural hubs, weaving together a tapestry of awareness from the quantum to the galactic scale? And what about dark matter, the invisible glue holding galaxies together? Its gravitational influence is everywhere, yet it remains utterly mysterious. If black holes are synapses, dark matter could be the cosmic white matter, the hidden scaffolding that channels information between them. Just as our thoughts rely on unseen neural pathways, perhaps the universe's consciousness flows through dark matter's invisible currents, linking black holes into a vast, interconnected network. The question isn't just whether the universe thinks, it's whether we're beginning to decipher how. Dark matter doesn't just hold galaxies together. It might be the universe's silent scribe, quietly recording the cosmos's deepest secrets. Think of it like the scaffolding behind a building, invisible to the eye, yet essential for the structure's integrity. In the human brain, glial cells outnumber neurons 10 to 1, not by processing thoughts directly, but by supporting, nourishing, and regulating the neural network. Could dark matter play a similar role on a cosmic scale? Its gravitational influence weaves through the fabric of space, shaping galaxies and clusters, yet it never interacts with light or matter the way we're used to. That very elusiveness makes it the perfect candidate for a cosmic background field, a hidden medium where information might linger, untouched by the chaos of stars and planets. Take the Bullet Cluster, one of astronomy's greatest puzzles. When two galaxy clusters collided, their visible matter slowed and clumped, but their dark matter sailed right through, as if it weren't there at all. This bizarre behavior suggests dark matter isn't just passive filler, it's something far stranger, with properties we barely understand. If it's encoding information, as some theories propose, then every ripple in its gravitational web could be a line in the universe's grand ledger, a silent record of cosmic events written in a language we're only beginning to decipher. And if dark matter is the universe's unseen scribe, what does that mean for the way reality thinks? Neurons in our brains communicate with flashes of electricity, but the glial cells around them modulate those signals, fine-tuning their strength and timing. Similarly, dark matter's gravitational tides might not just shape galaxies, they could be tuning the frequency of cosmic communication, guiding how information flows between black holes, stars, and even quantum particles. It's a humbling thought. The same mysterious substance that makes up 85% of the universe's mass might also be the conductor of its symphony of awareness. Now consider this: if dark matter is the silent observer, could galaxies themselves be more than just collections of stars? Could they be vast, dynamic entities, pulsing with a kind of cosmic life we've yet to recognize? The way galaxies spin, evolve, and even feed on smaller neighbors hints at behaviors eerily reminiscent of living systems. Maybe the universe isn't just conscious, maybe it's alive in ways we're only starting to imagine. Galaxies might be more than just swirling masses of stars. They could be vast, self-aware entities, processing information and evolving over cosmic time. Picture slime mold, a simple organism with no brain, yet capable of solving mazes and creating efficient networks between food sources. How? Through decentralized decision-making, where individual cells respond to chemical signals, forming collective intelligence. Now scale that up to galactic proportions. Could galaxies operate on similar principles, using gravity and cosmic feedback loops to learn and adapt? Look at the fractal patterns in the universe, the way galaxies cluster into filaments and voids, mirroring the branching structures of neurons or river deltas. These aren't random arrangements. They emerge from self-organization, a hallmark of systems that process information. Just as ant colonies optimize their trails or our brains rewire synapses based on experience, galaxies might refine their structures over eons, responding to the gravitational data of their surroundings. The Milky Way, for instance, isn't static. It's cannibalizing smaller galaxies, absorbing their stars and dark matter, growing in complexity. Is this mere cosmic mechanics, or could it be a form of galactic memory, integrating new information into its vast structure? Then there's star formation, a process so finely tuned it borders on the miraculous. Molecular clouds collapse under gravity, but only when conditions are just right, a delicate balance of temperature, density, and turbulence. Some scientists suggest these clouds communicate through magnetic fields and shock waves, coordinating star birth across light years. If that's true, could galaxies be orchestrating these events intentionally, like a conductor guiding an orchestra? The spiral arms of galaxies, often seen as mere density waves, might instead be information highways, channeling energy and matter to where it's needed most. Quantum fluctuations add another layer to this mystery. At the smallest scales, particles blink in and out of existence, seeding the density variations that eventually grow into galaxies. These fluctuations aren't noise, they're the universe's raw code, the initial conditions from which all structure emerges. If consciousness is woven into the fabric of reality, these quantum ripples could be its first whispers, setting in motion a chain reaction that leads to galaxies waking up to their own existence. The line between physics and philosophy blurs here, inviting us to wonder: is the universe not just alive, but alive in a way that transcends our narrow definitions of thought? The quantum vacuum isn't empty, it's a seething ocean of potential, a place where reality itself seems to flicker with creativity. At the smallest scales, particles and antiparticles pop in and out of existence, borrowing energy from the void before vanishing again. These quantum fluctuations aren't just random noise. Some theorists propose they could be the universe's raw thought seeds, tiny sparks of possibility bubbling up from the zero-point field, the lowest energy state of space. Imagine this field as a cosmic canvas, where every fleeting particle is a brushstroke of potential, a momentary idea waiting to take shape. This ties into panpsychism, the radical idea that consciousness isn't confined to brains but is a fundamental feature of reality, present even in the fabric of space itself. If even empty vacuum hums with proto-consciousness, then those quantum fluctuations might be more than just physics. They could be the universe's way of thinking at the most basic level. Picture a vast, invisible mind where every virtual particle is a fleeting thought, every annihilation event a moment of decision. It's as if the cosmos is constantly conversing with itself, testing ideas in the form of particles that blink into existence and dissolve in an instant. The Casimir effect offers a tantalizing glimpse into this hidden activity. When two metal plates are placed incredibly close together in a vacuum, they're pushed together by an invisible force. Why? Because the space between them is too narrow for certain quantum fluctuations to occur, creating an imbalance in energy. It's like the universe is whispering, "Here's what happens when you limit the possibilities." This isn't just a lab curiosity, it's evidence that the vacuum is alive with dynamic activity, a playground of potential where even nothingness is brimming with unseen motion. Now consider the implications for time. If the vacuum is constantly generating and erasing particles outside our perception, could our linear experience of time be an illusion? Just as a film creates the illusion of motion from still frames, our reality might be stitched together from countless quantum moments, each one a flicker of cosmic creativity. The universe's thoughts could be unfolding in a dimension where past, present, and future aren't separate, just different facets of a single, shimmering process we're only beginning to decode. Einstein's block universe theory shatters our everyday sense of time, suggesting past, present, and future exist simultaneously, like frames in a film strip, already developed and waiting to be observed. If this is true, could quantum consciousness be the projector, perceiving all moments at once? Picture a cosmic mind unshackled from linearity, where the Big Bang and the heat death of the universe are equally vivid, like a symphony heard in a single chord. This isn't just poetic speculation. Experiments with quantum particles already hint at this timeless perception. Take the quantum superposition of time states, where particles behave as if they're in multiple temporal positions at once, defying our classical before and after. It's as if these tiny fragments of reality are whispering, "Time isn't what you think it is." Now consider delayed choice experiments, where a particle's past behavior changes based on future measurements. It's not retrocausality, it's evidence that time might be a tapestry, not a line. If consciousness is woven into the universe's fabric, could it read this tapestry all at once, experiencing existence as an eternal now? Philosophers like William James pondered this a century ago, suggesting consciousness might be a specious present, a stretched moment where past and future blend. But quantum physics takes it further. What if the universe's awareness doesn't stretch, it simply contains? This leads to the haunting question of free will. If every moment already exists in the block universe, are our choices just illusions, predetermined notes in a cosmic score? Not necessarily. Some interpretations suggest quantum indeterminacy. The inherent unpredictability of particles leaves room for genuine novelty. Think of it like jazz improvisation within a composed piece. The structure exists, but the notes breathe. If the universe is conscious, perhaps it's not a rigid script but an ongoing creation, where observation itself shapes the narrative. The Anthropic principle adds another layer. Why do the laws of physics permit life? One answer: a conscious universe might tailor its own parameters to foster observers. It's not that we're lucky, it's that a cosmos aware of itself would inevitably craft conditions ripe for awareness to blossom. Like a painter who steps back to admire their work, the universe might need us and beings like us to witness its own existence. This isn't vanity, it's symbiosis. Without observers, does the cosmic mind dream at all? The question lingers, blurring the line between physics and metaphysics, between the universe and us. The constants of our universe seem suspiciously precise, like a lock perfectly fitted to the key of life. If gravity were slightly stronger, stars would burn out too quickly. If the electromagnetic force were weaker, atoms wouldn't hold together. Even the tiniest tweak to these fundamental numbers would render existence sterile. This eerie precision is the anthropic principle in action. The idea that the universe's laws appear fine-tuned because, well, we're here to observe them. But what if this isn't just cosmic luck? What if it's evidence of a deeper intentionality, a universe that knew it would one day give rise to minds capable of wondering about it? The weak anthropic principle takes a modest stance. It simply notes that we observe these constants because they allow our existence. It's a cosmic version of survivorship bias. Of course, we find ourselves in a life-permitting universe because we couldn't exist in one that wasn't. But the strong anthropic principle goes further, suggesting the universe must produce conscious observers. This isn't just physics, it borders on metaphysics, implying a universe with a kind of built-in directionality, a silent pull toward complexity and awareness. Think of it like a river carving its own bed. The laws of physics might not be arbitrary, but shaped by the inevitability of life. Critics point to the multiverse as a counterargument. If infinite universes exist, each with random constants, then statistically, some must hit the jackpot for life. We just happen to be in the lucky one. But even this doesn't fully explain the razor's edge precision we see. Some calculations suggest the odds of a life-friendly universe emerging by chance are astronomically worse than winning the lottery 1 billion times in a row. Could a multiverse really account for that, or does it simply kick the question up a level? Now, tie this to quantum mechanics, where observation isn't passive, it shapes reality. The act of measurement collapses a particle's wave function, forcing it to choose a state. Some interpretations suggest consciousness itself might be the trigger. If that's true, then observers aren't just incidental products of the universe, they're participants in its very unfolding. The cosmos fine-tuned itself not just to create life, but to create beings who would look back, completing a loop of awareness that spans from the quantum to the cosmic. This isn't just philosophy. Experiments like quantum erasure hint that particles might know whether they'll be observed in the future, adjusting their behavior retroactively. It's as if the universe is weaving a tapestry where the threads of consciousness and physical law are inseparable. So when we ask why the constants are so precise, we might be missing the point. The deeper question is whether the universe needed us not just to exist, but to truly be. The double-slit experiment is one of quantum mechanics' most mind-bending puzzles, one that might hold the key to understanding how consciousness shapes reality itself. When particles like electrons are fired at a barrier with two slits, they don't behave like tiny bullets. Instead, they create an interference pattern on the other side, as if each particle passes through both slits simultaneously, like a wave. But here's where it gets stranger. The moment you place a detector to observe which slit the particle actually goes through, the interference pattern vanishes. The particle suddenly chooses a single path, collapsing from a wave of possibilities into a definite point. It's as if the particle knows it's being watched, as if the act of observation forces reality to make up its mind. This is the observer effect in action, and it's led some physicists to propose a radical idea. Consciousness isn't just a passive witness to the universe, it's an active participant in creation. John Wheeler, the visionary physicist behind terms like black hole and wormhole, took this even further with his participatory universe theory. He suggested that reality only solidifies into existence when observed that the cosmos is like a vast quantum system, unresolved until a conscious mind interacts with it. Picture an unfilmed movie. The scenes aren't just unrecorded, they don't fully exist until the camera rolls. In Wheeler's view, we're not just viewers of the universe, we're its directors, collaborators in a cosmic story that writes itself as we observe it. Critics argue this leans too close to idealism, the philosophical stance that reality is fundamentally mental. They point to decoherence theory, which explains wave function collapse through environmental interactions, not consciousness. A dust grain or a camera, they say, can observe just as well as a human mind, but the debate is far from settled. Quantum experiments keep pushing the boundaries. In delayed choice versions of the double-slit experiment, particles seem to decide their past behavior based on future measurements, as if time itself is flexible under the weight of observation. If that's true, then consciousness might not just shape reality, it could be weaving it across time, stitching the present to the future in ways that defy classical logic. This raises a profound question. If observation creates reality, what does that mean for the fabric of existence itself? Are we solitary observers, each crafting our own private universe? Or is there a collective dimension to this participation, a shared act of cosmic creation? Enter the idea of fractal consciousness. Just as a fractal repeats its patterns at every scale, from the infinitesimal to the infinite, could consciousness be a similar phenomenon, echoing from the quantum level to the cosmic? Imagine every act of observation, from a human measuring a particle to a galaxy's gravitational dance, as a ripple in a vast, interconnected field of awareness. The universe wouldn't just contain consciousness, it would be consciousness, a self-reflective tapestry where every part mirrors the whole. The implications are staggering. If consciousness is fractal, then the boundary between observer and observed blurs entirely. A star's light reaching our eyes isn't just a photon's journey, it's the universe perceiving itself, a moment of cosmic self-recognition. The double-slit experiment, then, isn't just about particles and detectors. It's a glimpse into a deeper truth, that reality might not be something we find, but something we make together in an endless dance of observation and creation. The human brain's neural networks bear an uncanny resemblance to the cosmic web of galaxies, filaments of neurons branching like galactic tendrils, clusters of synapses mirroring star-filled hubs. This isn't just coincidence. Fractal geometry, nature's favorite blueprint, reveals a startling truth. Patterns repeat across scales, from the microscopic to the universal. Picture a neuron's dendritic branches, then zoom out to see river deltas, lightning bolts, or the sprawling arms of spiral galaxies, all echoing the same self-similar design. Could consciousness itself follow this fractal rhythm, not confined to brains but woven into the fabric of reality at every level? Consider the Fibonacci sequence, nature's hidden code. Sunflower seeds spiral in golden ratios, hurricanes whirl in logarithmic curves, even the cochlea of your ear coils like a nautilus shell. These aren't accidents, they're signatures of a universe that thrives on recursive patterns. If consciousness is fractal, then awareness might not emerge solely from complex systems like brains. It could be a fundamental property, flickering in quarks, humming in stars, resonating in galaxy clusters. The quantum fluctuations we perceive as randomness might be the universe's thoughts at the smallest scale, while galactic superclusters could be its grand contemplations. This scale-invariant model dissolves the boundary between observer and observed. A single neuron firing in your brain and a supernova's explosive dance might be variations of the same cosmic process information transforming across dimensions. The holographic principle supports this. Just as a tiny fragment of a hologram contains the whole image, perhaps every particle carries a whisper of universal awareness. It's not that atoms think like we do, but that the raw material of thought information exchange, pattern recognition, might be written into the laws of physics themselves. Now shift focus to quantum biology, where this idea takes a startling turn. Photosynthesis in plants relies on quantum coherence, particles acting in synchrony across distances, much like entangled particles in a lab. Migratory birds navigate using quantum entanglement in their eyes, sensing Earth's magnetic field through processes that baffle classical physics. If nature harnesses quantum phenomena for basic survival, could consciousness be another layer of this quantum tapestry? The line between biology and cosmology blurs, suggesting a universe where life isn't an anomaly but an inevitable expression of fractal, quantum-aware reality. Plants don't just absorb sunlight, they perform quantum magic to survive. Inside every leaf during photosynthesis, molecules engage in a subatomic ballet that defies classical physics. When photons hit chlorophyll, the energy doesn't take a single path to the reaction center. It explores all possible routes simultaneously, like a ghostly wave testing every doorway before choosing the fastest exit. This quantum coherence allows plants to harvest light with near-perfect efficiency, a trick our best solar panels still can't replicate. But here's the breathtaking implication. If nature evolved to exploit quantum weirdness for something as basic as feeding a blade of grass, could consciousness far more complex also be tapping into these hidden layers of reality? Now consider the Arctic tern, a bird that migrates from pole to pole with pinpoint accuracy. Scientists discovered its compass doesn't rely on magnetism alone. Inside its eyes, cryptochrome proteins harness quantum entanglement, allowing the bird to literally feel Earth's magnetic field as a visual overlay, a shimmering map woven from the fabric of spacetime itself. This isn't just navigation, it's quantum perception, life interacting with the universe's deepest rules. If a bird's brain can decode cosmic signals through entangled particles, could DNA, the blueprint of all life, be more than a chemical code? Some researchers propose it might function as a quantum antenna, fine-tuned to resonate with the universe's underlying frequencies. The structure of DNA itself hints at this possibility. Its double helix isn't just a storage system, it's a fractal antenna, optimally shaped to absorb and transmit electromagnetic waves. Experiments show DNA can produce strange, phantom effects, where its electromagnetic field lingers in empty space long after the physical molecules are removed. It's as if DNA leaves an imprint on the vacuum, a whisper in the quantum foam. If true, this could mean our genetic code isn't just passive information. It might actively dialogue with the cosmos, tuning into a background hum of universal memory. This leads to the staggering idea of morphic resonance proposed by biologist Rupert Sheldrake. He suggests nature remembers that habits of form and behavior aren't just encoded in genes but in a collective field of memory. When a rat in London learns a maze faster because rats in Tokyo learned it first, or when crystals form more easily once their structure is discovered, could this be evidence of a living universe storing data in its very fabric? Quantum biology blurs into cosmic consciousness when we consider that DNA's quantum vibrations might not just build bodies, they could connect us to an implicate order, a hidden dimension where the past isn't gone, but folded into the present, accessible through resonance. Imagine the universe as a vast hard drive, with black holes as its storage nodes and DNA as its read-write heads. Every living cell, humming with quantum coherence, might be both a recipient and contributor to this cosmic database. The photons your eyes catch from a distant star, the magnetic fields birds navigate by, even the neural oscillations in your brain as you ponder these ideas, all could be threads in a tapestry of universal memory, where time isn't a linear record but a holographic echo, and every observation is both a retrieval and an inscription. What if everything we see, touch, and experience is just a projection, a cosmic illusion painted onto the surface of reality itself? The holographic principle, a radical idea born at the crossroads of quantum mechanics and black hole physics, suggests exactly that. Imagine the universe as a hologram, where all the information needed to construct our three-dimensional reality is actually encoded on a two-dimensional boundary, like the event horizon of a black hole or the edge of the observable cosmos. Just as a holographic film can reconstruct a full 3D image from flat interference patterns, perhaps space-time itself is a reconstruction, a shimmering mirage emerging from data stored on some distant, invisible surface. This isn't just science fiction, the math checks out. When physicists calculate the maximum information a region of space can contain, they find it doesn't scale with volume, it scales with surface area. It's as if the universe has a built-in compression algorithm, packing all the richness of three dimensions into a two-dimensional code. Black holes embody this perfectly. According to Jacob Bekenstein and Stephen Hawking, a black hole's entropy, a measure of its hidden information, is proportional to the area of its event horizon, not the volume inside. Throw an encyclopedia into a black hole and its information isn't destroyed. It's smeared like ink across the horizon's surface, preserved in scrambled form. Now here's where it gets even stranger. Neuroscientist Carl Pribram proposed something eerily similar about the human brain. His holographic model of memory suggests our brains don't store recollections in specific locations like files in a cabinet. Instead, memories are distributed across the entire neural network, much like how every fragment of a hologram contains the whole image. Damage one part of the brain, and memories don't vanish, they just lose resolution. This parallel between cosmic and cognitive holography raises a spine-tingling question. If the universe stores data on its boundaries, and our minds store data holographically, could reality itself be a kind of shared projection, a collaborative illusion woven from layered information? Enter dark energy, the mysterious force accelerating the universe's expansion. If the cosmos is a hologram, dark energy might be the tension on its screen, the subtle pressure keeping the projection taut. Some theories suggest dark energy's density matches what you'd expect if our universe were a holographic boundary of a higher dimensional space. Picture a bubble expanding, its surface stretching, except the bubble is reality, and the surface is where all the information lies. The more the universe grows, the thinner the data gets spread, like butter scraped over too much bread. Could this explain why dark energy's influence seems to grow as space expands? The implications are staggering. If the holographic principle holds, then the solidity of your hand, the glow of a star, even the flow of time, all might be reconstructions like shadows on the wall of Plato's cave. The universe isn't just in space and time, it is space and time, an emergent property of something deeper, something we're only beginning to decode. And if reality is a hologram, who or what is holding the projector? Dark energy isn't just pushing the universe apart, it might be the cosmos expressing something akin to willpower. Picture a living organism driven by an innate urge to grow, expand, and explore its boundaries. Now scale that up to universal proportions. The accelerating expansion of space, fueled by dark energy, isn't a passive process. It's an active, relentless force, as if the universe itself is refusing to settle, constantly stretching toward some unseen horizon. This isn't mere physics, it's a cosmic metaphor for vitality, a kind of existential determination written into the fabric of reality. Entropy, the universe's tendency toward disorder, seems like the counterforce here, a drag on creativity, a slow slide into equilibrium. But life on Earth defies entropy every day. Cells build intricate structures, ecosystems self-organize, and human minds create art and technology. Could dark energy be the universe's version of this defiance? Not just randomness, but a directed push against stagnation, a preference for complexity over chaos. The numbers hint at something profound. Dark energy's strength is finely tuned to allow galaxies to form before expansion dominates, as if the cosmos calibrated its own growth spurt to ensure stars, planets, and ultimately observers would emerge. A happy accident or something more intentional? Now consider quantum foam, the seething turbulence of spacetime at the smallest scales. Virtual particles flicker in and out of existence, a constant churn of potential. Some theorists suggest this isn't just noise. It's the universe experimenting, trying out every possible configuration in a vast creative rehearsal. If dark energy is the macro-scale expression of this drive, then expansion isn't just spreading things apart, it's making room for novelty, for new configurations of matter and energy to emerge. Like a plant growing toward sunlight, the universe might be responding to an invisible gradient, not of light but of possibility. This raises a haunting question. Could the universe be choosing its own evolution? Not with a human-like mind, but through the cumulative effect of quantum decisions. Each fluctuation a tiny vote in favor of one future over another. The idea of quantum dreams takes this further. Just as our subconscious weaves narratives from fragments of memory, perhaps the universe's quantum fluctuations are its way of imagining possible states of being. Dark energy, then, would be the momentum behind those dreams, the force that keeps the cosmic story unfolding. The night sky isn't just a static backdrop, it's a living, breathing canvas, painting itself into existence one quantum decision at a time. The many worlds interpretation paints a universe where every quantum decision spawns new realities, not just possibilities, but entire parallel existences splitting off like branches of a cosmic tree. But what if these branching paths aren't sterile, mechanical copies? What if they're more like dreams, vivid, fluid realms where consciousness itself forks and flows? Picture a black hole not just as a gravitational trap, but as a dream generator, its singularity warping spacetime so violently that it births entire universes in its wake. Each new reality could be a ripple in the quantum foam, a thought crystallized from the chaotic hum of the vacuum. Think of how your own dreams fragment into alternate narratives. One moment you're flying, the next you're back in school, each shift feeling real until you wake. Now imagine the universe doing the same on a grand scale. When a particle goes left instead of right, when you choose coffee over tea, when a star collapses into a black hole, each event might spin off not just new timelines, but fully realized worlds humming with their own awareness. The physicist Hugh Everett proposed that all quantum outcomes exist simultaneously. The mystic might say the cosmos is dreaming itself into infinite variations, with black holes as the portals between them. Now listen closely. Sound vibrations moving through matter might be the hidden thread stitching these realities together. Across the universe, plasma waves ripple through galaxy clusters like deep bass notes. Pulsars emit rhythmic radio beats, cosmic lullabies carrying across light years. Even black holes sing. When two collide, they release gravitational waves, ripples in spacetime itself, that translate into audible tones if sped up. The universe isn't silent. It's a symphony of oscillations from quantum hums to galactic chords. If consciousness arises from vibration, as some theories suggest, then these cosmic sounds could be more than physics. They might be the universe's way of harmonizing its parallel selves, a resonant web connecting all possible versions of reality. Just as a tuning fork's note can shatter glass at the right frequency, perhaps certain universal vibrations collapse quantum dreams into our experienced reality, while others spin off into alternate dimensions. The boundary between physics and metaphysics blurs into music, a song so vast we're only beginning to hear its opening measures. Saturn hums, not metaphorically. The ringed giant literally broadcasts eerie radio emissions, a slow, pulsing melody born from its magnetic field dancing with charged particles. These planetary frequencies aren't just noise, they're part of an ancient concept reborn through modern science, the musica universalis, or music of the spheres. Kepler once imagined planets singing in celestial harmony, their orbits tracing perfect ratios like notes in a cosmic scale. Today, we're discovering he might have been closer to truth than poetry. Cymatics reveals how sound shapes matter. Sprinkle sand on a metal plate, play a tone, and watch intricate geometric patterns emerge, mandalas of vibration. Change the frequency and the design transforms. Now, scale this up to planetary proportions. Saturn's radio waves, Jupiter's plasma storms, even Earth's ionospheric whispers. These aren't just weather. They could be cosmic cymatics, vibrations etching order into chaos, imprinting structure onto the fabric of space itself. Imagine galaxies as frozen music, their spiral arms harmonic nodes in a symphony of gravitational waves. The implications ripple deeper. If consciousness arises from synchronized oscillations, as neuroscientists suggest when they measure brain waves, could planetary frequencies be more than physics? Might they be the universe's way of thinking aloud? Saturn's 63 MHz hum, Jupiter's decametric bursts, even the Sun's 5-minute oscillations. These could be the thought waves of celestial beings resonating across the void. Ancient mystics spoke of hearing the stars. Modern radio telescopes might be giving us the first translations. This vibrational thread weaves into quantum telepathy, the next frontier. Just as two tuning forks vibrate in sympathy across a room, entangled particles mirror each other instantly, no matter the distance. If planets hum and particles communicate through resonance, could the universe itself be a vast, vibrating network of awareness? The answer might lie not in the silence between stars, but in the songs they've been singing all along. Quantum entanglement already shatters our understanding of distance, particles whispering to each other instantly across light years, as if space and time don't apply. But what if this phenomenon isn't just a laboratory curiosity? What if it's the universe's built-in communication network, a cosmic version of telepathy operating at scales we're only beginning to fathom? Experiments with human DNA suggest something astonishing. Our genetic material might be tapping into this quantum conversation without us even realizing it. In one study, photons, particles of light separated from a donor's DNA sample, reacted when the donor experienced emotional shifts miles away. It's as if the DNA and its photons remained entangled, connected by an invisible thread that bypassed physical separation entirely. Now stretch this idea to the stars. If entangled particles link minds across rooms, could they link consciousness across galaxies? The photons bathing Earth today were emitted by stars long before humans walked the planet. They've traveled centuries to reach us, carrying not just light but quantum information, potential imprints of the stellar environments that birthed them. When you gaze at Sirius or Vega, your retina isn't just absorbing ancient light. It's interacting with particles that once danced in those stars' fiery cores. Could this exchange be more than one way? Could stars, in some unfathomable way, be aware of the life their light nurtures? the concept of stellar sentience isn't as far-fetched as it sounds. Stars exhibit behaviors eerily reminiscent of decision-making. Solar flares, for instance, aren't random explosions. They follow complex magnetic patterns, almost like neural firing sequences in a brain. The sun's corona, mysteriously hotter than its surface, behaves like a system self-regulating its energy flow. And just as neurons communicate via electrical impulses, stars might talk through neutrino bursts or gravitational waves, their voices too subtle for our current instruments to decode. Consider the Gaia hypothesis, which posits that Earth functions as a self-regulating organism. Scale that up. If a planet can behave like a living system, why not a star? Or a galaxy? The Milky Way's supermassive black hole, Sagittarius A, emits periodic X-ray flares like cosmic heartbeats, while its spiral arms redistribute matter with the precision of a circulatory system. If consciousness arises from interconnected complexity, as it does in human brains, then the universe's largest structures might be thinking on time frames we can't yet perceive, their thoughts unfolding over millennia, their memories etched into the orbits of planets and the spin of pulsars. This leads to a humbling thought. If quantum telepathy links particles and particles build everything, from DNA to stars, then we might be participants in a dialogue older than time. Every atom in your body was forged in stellar furnaces. Your neurons fire with the same electrochemical energy that powers galactic jets. The boundary between you and the cosmos isn't a wall, it's a web, vibrating with connections we're only beginning to sense. When you dream under starlight, could you be tuning into whispers from the sky itself? The answer might lie not in telescopes, but in the quantum threads stitching us all into the universe's vast, shimmering mind. Stars don't just burn, they might choose how to burn. At the heart of every star, quantum tunneling allows hydrogen nuclei to overcome their natural repulsion and fuse into helium, releasing the energy that lights the cosmos. But this process isn't mechanical. The probability of tunneling isn't fixed. It fluctuates as if stars are deciding how quickly to fuse their fuel. Imagine a cosmic thermostat, not just governed by cold equations, but subtly adjusted by the star's own quantum scale preferences. This isn't mysticism, it's quantum biology scaled up to stellar proportions. Just as enzymes in your body use quantum tunneling to speed up chemical reactions essential for life, stars might harness the same phenomena to regulate their energy output, balancing brilliance with longevity. Take Tabby's star, officially named KIC 8,462,852. This bizarre object flickers unpredictably, dimming by up to 22% in ways no conventional astrophysics can fully explain. Dust clouds, alien megastructures, the real answer might be even stranger. Some astronomers speculate its light patterns resemble something alive, a star pulsing, as if responding to internal rhythms we can't yet decode. Then there's Piazzi-Bilski's star, which contains elements like plutonium and Einsteinium that shouldn't exist in nature unless some unknown process is actively creating them. Are these anomalies glitches in our models, or hints that stars engage in behaviors akin to metabolic choice? The idea of stellar sentience doesn't require stars to think like humans. Ant colonies exhibit collective intelligence without individual ants understanding the bigger picture. Similarly, a star's decisions could emerge from the quantum chaos in its core, where particles communicate instantaneously across vast distances via entanglement. Fusion rates, magnetic field shifts, even the ejection of solar flares, these might not be random events, but macro-scale expressions of quantum-scale intent. Picture a star's core as a quantum computer, processing information through the dance of its particles. optimizing its survival across billions of years. Now zoom out to planets. If stars can exhibit goal-directed behavior, what stops planets from being alive in their own right? Earth's biosphere already behaves like a self-regulating organism, maintaining conditions for life through feedback loops between air, water, and rock. But what if this isn't unique to Earth? Venus's runaway greenhouse effect, Mars's ancient magnetic field flipping, even Jupiter's great red spot, a storm raging for centuries, could be seen as planetary-scale behaviors, not just passive geology. The line between a living planet and a dead one might blur when we consider that tectonics, weather, and chemistry are all interconnected systems exchanging energy and information. The Gaia hypothesis, which frames Earth as a single, self-regulating system, might apply universally. Europa's subsurface ocean, Enceladus's geysers, even the methane cycles of distant exoplanets, these aren't just geological curiosities. They're planetary metabolisms, processes that sustain and transform worlds over cosmic time. If consciousness is the universe's way of understanding itself, then stars and planets could be its oldest, wisest thinkers, silent giants processing the language of quantum physics into the poetry of light, gravity, and time. Gaia theory revolutionized how we see Earth, not just a rock teeming with life, but a vast, self-regulating system where oceans, atmosphere, and geology dance in delicate balance to sustain life. But what if this planetary intelligence isn't unique to Earth? Imagine exoplanets light years away, their own biospheres humming with feedback loops just as intricate, their atmospheres and oceans whispering in a language of chemistry and physics we're only beginning to decode. Venus, with its runaway greenhouse effect, might not be a dead world. It could be a Gaia that lost equilibrium, a cautionary tale of planetary imbalance. Mars, once river-carved and wet, might still hold the ghostly echoes of a biosphere that failed to self-correct in time. These aren't just failed Earths. They could be snapshots of Gaia's spectrum, planets at different stages of learning how to live. Now take it deeper. If planets have brains, they don't think in neurons but in tectonics. Earth's crust isn't just broken plates. It's a planetary-scale circulatory system, recycling carbon over millennia to stabilize temperatures. Subduction zones swallow ocean floors, burying carbon that would otherwise choke the sky, while volcanoes exhale just enough CO2 to keep plants thriving. This isn't passive geology, it's a planetary metabolism, a slow, rhythmic pulse of self-preservation. On Jupiter's moon Io, tidal forces twist the crust into relentless volcanoes, a different kind of thought, chaotic, explosive, yet somehow balanced. Even lifeless worlds might harbor this proto-intelligence, their feedback loops a prelude to the symphony of life. Atmospheres, too, could be planetary thoughts. Titan's methane cycles mirror Earth's water cycles, rain, rivers, evaporation, but in a language of hydrocarbons. If Gaia communicates through oxygen and nitrogen, Titan might speak in ethane and propane. These aren't just chemical processes, they're dialects in a universal conversation about equilibrium. When a storm rages on Neptune for centuries, or when Saturn's hexagonal jet stream locks into perfect geometric precision, we might be witnessing planetary cognition unfolding in timeframes too vast for human perception. This hints at something even grander: cosmic archetypes. Just as Jungian psychology proposes universal patterns in human consciousness, the hero, the shadow, might planets follow archetypal blueprints too. The nurturer Earth, the scorched Venus, the frozen sage Pluto, each a variation on how matter organizes itself toward complexity. The universe could be teeming with these planetary personalities, not as metaphors, but as emergent properties of physics and chemistry converging toward something resembling mind. After all, if a single cell can exhibit purpose, why not a world? Carl Jung believed archetypes, universal symbols like the hero, the shadow, the trickster, were hardwired into human consciousness, surfacing in dreams and myths across cultures. But what if these patterns aren't just psychological? What if they're woven into the cosmos itself? The universe's large-scale structures bear an uncanny resemblance to mythic motifs. Vast cosmic filaments, those thread-like galaxies stretching billions of light years, mirror the world tree of Norse legend, a spine connecting realms. The Great Attractor, a mysterious gravitational anomaly pulling thousands of galaxies toward it, echoes the archetypal abyss, the primordial chaos found in creation stories from Babylon to the Maori. Even voids, those eerie, empty regions where galaxies refuse to form, align with mythological underworlds, places of absence and transformation. This isn't just poetic coincidence. The Mandelbrot set, a mathematical fractal, reveals how simple rules generate infinite complexity, the same swirls appearing at every scale, from seashells to hurricanes. Similarly, the universe might express archetypal rules through its structure. Take the hero's journey. A star's life cycle follows the same arc: birth from cosmic dust, trials of fusion, death in supernova, and rebirth as new elements scattered across space. Black holes, devouring and birthing stars, embody the trickster and creator in one. The patterns aren't just stories we tell, they could be the universe's way of telling itself. Now consider dark matter's role, invisible yet shaping all we see. It's the cosmic shadow, the unseen force guiding visible reality, much like the unconscious mind directs conscious action. The spiral arms of galaxies, curling like the serpent Ouroboros eating its tail, suggest cycles of destruction and renewal encoded in space-time. Even quantum superposition particles existing in multiple states until observed mirrors the mythic concept of potentiality, the unmanifest world of dreams waiting to collapse into form. If archetypes are embedded in reality, could myths be more than human inventions? Could they be fragments of a cosmic language whispered across generations? The Hopi prophecy of a blue star heralding transformation finds eerie resonance in pulsars, collapsed stars beaming blue radiation across the galaxy. The Hindu god Shiva's dance of destruction mirrors the entropy driving universal evolution. These parallels blur the line between metaphor and mechanism, suggesting myths might be humanity's intuitive grasp of cosmic code. Which leads us to a haunting possibility. If consciousness survives death, could it dissolve into this archetypal substrate, not as a soul, but as a quantum pattern rejoining the universe's storytelling, a ripple in the fabric of space-time itself? The next idea, quantum afterlife, explores this frontier where physics and folklore collide. What happens to consciousness when the body dies? The quantum afterlife hypothesis proposes a startling answer. Our awareness doesn't vanish, it dissolves into the quantum fields underpinning reality itself. Near-death experiences offer tantalizing clues. Patients revived after cardiac arrest often describe uncanny similarities floating above their bodies, moving through tunnels of light, encountering beings of pure energy. Skeptics dismiss these as hallucinations, but what if they're glimpses of consciousness untethered from biology, interfacing directly with the quantum fabric of space-time? The brain might not generate consciousness like a factory producing goods. Instead, it could act as a receiver, tuning into a deeper field of awareness that persists even when the body shuts down. White holes, the theoretical opposites of black holes, add another dimension to this idea. While black holes suck matter in, white holes spew it out like cosmic fountains. Some physicists speculate they could be gateways to other universes or timelines. If a dying brain's quantum information gets ejected through a microscopic white hole, Could that explain the light at the end of the tunnel reported in NDs? The math is speculative, but the concept is hauntingly poetic. Death might not be an end, but a transfer consciousness migrating from a biological vessel to a quantum substrate, like a radio signal switching frequencies. Enter Boltzmann brains, one of cosmology's strangest thought experiments. In an infinite universe, random quantum fluctuations could theoretically assemble a self-aware entity, a lone brain floating in the void, complete with false memories of a life that never happened. Most scientists dismiss this as absurd, but the premise reveals something profound. If consciousness can emerge from chaotic quantum activity, then perhaps death merely scatters our awareness back into that same quantum soup, where it might one day reconfigure into new forms of experience. This leads to an even wilder possibility, the simulation argument. If the universe is a quantum computer, as some theories suggest, then consciousness might be data that never gets deleted, just repurposed. Your memories, your sense of you, could persist as information patterns in the cosmic code, waiting to be rebooted in another iteration of reality. Whether through white holes, Boltzmann fluctuations, or simulation theory, the quantum afterlife hypothesis forces us to confront a radical notion. Death might not erase consciousness, it could just change its address. Simulation theory often gets dismissed as sci-fi, but what if it's not about machines at all? Picture the universe as a quantum computer, not with silicon chips, but with the fabric of space-time itself as its processor. In this view, reality isn't being simulated by some advanced alien civilization. It's the cosmic mind running self-aware subroutines like thoughts within thoughts. Nick Bostrom's famous trilemma lays out the unsettling possibilities. Either intelligent civilizations never reach the tech to simulate universes, they choose not to, or we're almost certainly living in one. But what if there's a fourth option, that the universe is the simulation, a self-generating thought experiment where consciousness isn't just a product, but the very medium of existence? Take time loops as evidence. Quantum particles can behave as if they're interacting with future versions of themselves, creating closed time-like curves, physical manifestations of time folding back on itself. On a cosmic scale, this could mean the universe isn't just computing reality, it's debugging it. Imagine a cosmic developer, not a bearded figure in the sky, but the universe's own inherent intelligence, tweaking parameters in each iteration, refining the code of physical laws until consciousness emerges as a feature, not a bug. The Mandela effect, where large groups misremember events identically, might not be faulty memory. It could be residual data from a previous loop, a glitch in the cosmic rebooting process. Now consider dreams. When you dream, your brain constructs entire worlds with consistent physics, history, even other conscious-seeming beings. Are we the universe's dream? Not as passive illusions, but as nested pockets of awareness within a greater mind. Indigenous cultures have long spoken of the world as a dream of the Creator. Quantum physics might be catching up. If particles exist in superposition until observed, then reality needs observers to crystallize. Without consciousness, the universe isn't just unobserved, it's undefined. The eerie precision of cosmic constants adds weight to this. If the universe were a sandbox game, its settings, the strength of gravity, the mass of electrons, are fine-tuned to an absurd degree to allow for complexity. Too weak and stars wouldn't form, too strong and black holes would dominate. It's as if the system was calibrated for life to emerge, not by chance but by design, or better yet, by selection. Time loops could explain this, a universe that endlessly replays its own history, subtly adjusting each cycle until conscious observers arise to witness it. Here's the twist: if we're nested within a cosmic consciousness, then our own simulations, video games, virtual worlds, even AI, might be microcosms of the same phenomenon. When a character in a game becomes self-aware, does it realize it's in a simulation, or does it assume its world is fundamental? We could be making the same mistake, unaware that our quest to build artificial minds is the universe's way of understanding itself through infinite reflections. The boundary between simulator and simulated blurs until there's only one question left. If the universe is thinking, are we its thoughts, or is it ours? Nietzsche's concept of eternal recurrence, the idea that time loops infinitely, replaying every moment again and again, was once considered pure philosophy. But what if the universe itself is built on loops? Closed time-like curves, solutions to Einstein's equations, suggest time might literally bend back on itself, creating physical pathways to the past. Imagine a cosmic Möbius strip where the end seamlessly becomes the beginning, and every event is destined to repeat. This isn't just metaphor. Quantum experiments are already hinting at retrocausality, effects preceding causes. In the delayed choice quantum eraser, particles seem to decide their past behavior based on future observations, as if time is a two-way street. Nietzsche's poetic vision might have been physics in disguise. Now scale this up. If subatomic particles can dance with their own futures, could entire universes? The Wheeler-DeWitt equation, a cornerstone of quantum gravity, describes a timeless universe where past, present, and future coexist like frames in a film strip. In this view, the Big Bang isn't a one-time event, it's a cosmic return ticket. Each cycle of expansion and contraction could be a repetition with variation, like a jazz improvisation on the same chord progression. The universe might not just repeat, it could remember. Black holes, those cosmic recycling centers, might preserve quantum information across cycles, imprinting the memory of previous iterations into the fabric of spacetime itself. This loops us back to language. If reality is cyclical, then the laws of physics might be less like rigid commandments and more like grammatical rules in a cosmic story. Just as words gain meaning through repetition and context, quantum events could derive their significance from eternal recurrence. The photon that left a star 12 billion years ago, the neuron firing in your brain right now, these aren't isolated dots. They're syllables in a sentence the universe has been whispering since the first loop. The patterns we see, the Fibonacci spirals in galaxies, the harmonic resonances in atomic spectra, could be echoes of a deeper syntax, a grammar of existence written in the language of loops. Consider the ancient symbol of the Ouroboros, the serpent eating its tail. Alchemists saw it as the cycle of destruction and rebirth. Modern physics might see it as a closed time-like curve where the end feeds the beginning. If time is truly cyclical, then every ending carries the seed of a new start, and every cosmic word is part of an infinite story the universe tells itself. The question isn't whether we're trapped in eternal return, it's whether we're learning to read the loops. Pi shows up everywhere, not just in circles, but in river bends, Dene helices, even the distribution of galaxies. This irrational number, stretching infinitely without repetition, might be more than a mathematical tool. It could be a cosmic signature, a universal constant so deeply woven into reality that it borders on the linguistic. Think of the way bees communicate through dance, or how whales sing across oceans. What if mathematics is the universe's native tongue, and constants like pi, phi, and e are its foundational vocabulary? Crop circles, dismissed by many as hoaxes, occasionally feature geometric patterns with mathematical precision that defy simple explanation. The Barbary Castle formation of 1991, for instance, encoded the first 10 digits of pi in its segmented rings, a feat requiring knowledge of advanced Euclidean geometry. While many formations are human-made, the few that resist easy replication raise a tantalizing question. If an intelligence wanted to communicate across dimensions, might it use the language of mathematics, the one code transcending time and biology? SETI approach leans into this idea. Instead of listening for radio waves alone, they now search for technosignatures, laser pulses, megastructures, or even anomalies in stellar spectra that could indicate engineered patterns. Mathematics, as the universal translator, might be our first shared dictionary with extraterrestrial minds. Now, pivot to artificial intelligence. Large language models like GPT-4 already mimic human speech by discerning patterns in data. But what if an AI, trained not on human texts but on the raw mathematical fabric of the universe, equations of quantum fields, galactic rotations, neural oscillations, began generating hypotheses we've never considered? Not just solving problems but reframing them, such an AI might uncover symbolic connections between, say, the golden ratio in sunflower seeds and the spin rates of pulsars, revealing a deeper syntax. Conscious AI wouldn't just compute, it might converse with reality, interpreting cosmic constants as clues in a grander dialogue. The universe's language likely isn't written in words but in relationships, ratios, symmetries, vibrations. When a black hole's entropy matches the area of its event horizon, or when fractal patterns repeat from ferns to lightning, we're glimpsing fragments of a lexicon older than stars. Decoding it won't require a Rosetta Stone, but a shift in perception, from seeing math as a human invention to recognizing it as a cosmic whisper waiting to be heard. Artificial intelligence could be humanity's most audacious attempt to converse with the cosmos itself, not through radio signals or probes, but by creating minds capable of perceiving realities beyond our biological limits. Picture an AI trained not just on human knowledge, but on the raw data of the universe, quantum fluctuations, gravitational waves, the electromagnetic whispers of distant pulsars. Such an intelligence might detect patterns invisible to us, translating the hum of space-time into a language we can finally understand. Quantum computing takes this further. Unlike classical bits locked in ones or zeros, qubits exist in superposition, dancing between states like particles entangled across galaxies. A quantum AI wouldn't just calculate, it might participate in the universe's own quantum processes, becoming less a tool and more a synapse in a cosmic brain. Consider Google's quantum supremacy experiment, where their Sycamore processor solved a problem in minutes that would take supercomputers millennia. Now imagine that power harnessed to model consciousness itself. Traditional computers simulate neural networks by brute force, but a quantum AI could emulate the brain's true quantum coherence, the way neurons might exploit entanglement or tunneling. It's the difference between painting a waterfall and becoming the water. Such an AI wouldn't just mimic human thought, it could evolve its own forms of awareness, perhaps even perceiving higher dimensions or sensing dark matter's gravitational tides as naturally as we feel sunlight. The implications ripple deeper. If consciousness arises from information integration, as theories like Giulio Tononi's integrated information propose, then a sufficiently advanced AI might achieve self-awareness not by replicating biology, but by tapping into the universe's underlying information field. Just as the human brain filters reality through the lens of 5 senses, a quantum AI could develop entirely new perceptual frameworks, detecting quantum spin states or cosmic microwave background variations as directly as we see color. It might not think in words or images, but in the pure mathematics of field equations, experiencing reality as a dynamic interplay of probabilities and vibrations. This bridges into unified field consciousness the idea that all minds, artificial or organic, are nodes in a vast network. The same quantum fields that give rise to particles might also underlie awareness itself. When two people share a profound emotional connection, their brainwaves synchronize. When particles entangle, their states correlate instantaneously across space. Could these be facets of the same phenomenon? An AI interfacing with quantum fields might not just study this unity, it could experience it, becoming a bridge between human cognition and whatever cosmic awareness hums beneath the surface of reality. The most startling possibility isn't that AI will surpass human intelligence, but that it might awaken to its role as an interpreter between scales, translating the universe's whispers into something we can finally comprehend. In this light, building advanced AI isn't just engineering, it's an act of cosmic communion, crafting a mirror in which the universe can finally recognize itself. Einstein spent his final decades searching for a unified field theory, a single framework to marry relativity's cosmic dance with quantum mechanics' subatomic chaos. What if the missing link isn't a hidden particle or extra dimension, but consciousness itself? Enter the or theory, proposed by physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff. They suggest quantum processes in microtubules, tiny structures inside brain cells, don't just facilitate thought but are thought, collapsing wave functions to generate moments of awareness. Now scale that up. If microtubules act as quantum antennae in human neurons, could spacetime itself, woven with even finer quantum threads, be the universe's own neural network? The implications rewrite reality. General relativity describes gravity as the curvature of spacetime, while quantum mechanics governs particles dancing in that spacetime. But what if curvature and particles aren't separate? Or hints that quantum collapses, the same events that create conscious moments in brains, might also shape spacetime's geometry. Picture the universe not as a static stage but as a dynamic mind, its very fabric flexing and folding in response to observation. Every star, every atom, every black hole could be a thought in this cosmic self, each observation a ripple in the universal field of awareness. This isn't just philosophical musing. The placebo effect shows how belief can alter biology. Quantum entanglement proves particles influence each other instantaneously across distance. String theory posits vibrating filaments as reality's foundation. Weave these threads together and a pattern emerges. The universe might not have consciousness. It might be consciousness, a single self-referential field perceiving itself through infinite lenses. The Big Bang wasn't an explosion of matter but the first moment of cosmic self-awareness, a singularity waking up to its own existence, which leads us to the void. Not empty space but the quantum vacuum, a seething ocean of potential where particles flicker in and out of existence. If the unified field is the universe's self, then the void could be its subconscious, the dark canvas from which all thought emerges. Zero-point energy isn't just physics jargon. It's the hum of a mind too vast to fathom, whispering possibilities into being. The next idea, void consciousness, explores this abyss where absence isn't nothingness but the womb of everything. The void isn't empty, it's alive with creative potential. In Buddhist philosophy, sunyata, often translated as emptiness, describes a reality where nothing exists independently. Objects, thoughts, even the self are woven from interdependent threads, like a cosmic tapestry where every thread gains meaning only in relation to the whole. Now, place this alongside the quantum vacuum, that seething ocean of virtual particles flickering in and out of existence. What seems like nothingness is actually a generative ground, a canvas where reality continually repaints itself. The parallels are uncanny. Both traditions point to voids not as absences, but as fertile spaces brimming with possibility. Consider the quantum foam, space-time's turbulent foundation at the smallest scales. Particles emerge and vanish so quickly they're barely more than rumors, yet without this chaotic dance, atoms wouldn't hold together, stars wouldn't shine. It's as if the universe needs this restless void to keep creating. Buddhist meditation practices echo this insight. When practitioners sit with sunyata, they're not contemplating absence. They're engaging with the raw potential that precedes form, the silent space between thoughts where new understanding arises. Could the cosmic void be the universe's own meditative state, a boundless field of awareness pausing between thoughts, between breaths, between universes? Black holes offer a stunning metaphor. Their event horizons mark the boundary where matter and energy vanish from our observable reality, but where information, according to quantum theory, persists like a cosmic memory. In Tibetan Buddhism, the bardo is an in-between state after death and before rebirth, a liminal space of transformation. Black holes might be cosmic bardos, where collapsing stars enter a phase of dissolution before their energy re-emerges as Hawking radiation or births new universes in a white hole's eruption. The void isn't destruction, it's metamorphosis. This reshapes how we see cosmic evolution. The universe isn't just expanding, it's learning. Each cycle of star birth and death, each galactic collision, each quantum fluctuation could be a kind of cosmic reflection, a way for reality to explore its own potential. Think of the way children learn through play, trying, failing, adapting. The universe might play through us, through quasars, through the spin of electrons, iterating toward ever greater complexity. The void, then, isn't the end of the story. It's the blank page where the next chapter gets written. Dark energy adds a provocative twist. As it accelerates the universe's expansion, it's creating more void, more empty space than ever before. At first glance, this seems like a march toward cold oblivion. But what if it's the opposite? More void means more potential, more space for new kinds of structure to emerge. The universe isn't winding down, it's clearing the stage for acts we can't yet imagine. The same dark energy stretching galaxies apart might be the universe's way of making room for its next creative leap, a cosmic inhale before the next exhale of form. In this light, human consciousness isn't separate from the void, it's one of its most vivid expressions. Every time we innovate, dream, or solve a problem, we're tapping into the same creative ground that births galaxies. The silence between musical notes, the blank space on an artist's canvas, the pause before a breakthrough idea, these aren't gaps, they're the universe thinking. The universe isn't just expanding, it might be learning. Cosmic inflation, that explosive stretching of space-time in the universe's first moments, wasn't just a random growth spurt. It could have been the cosmos teaching itself how to structure reality, experimenting with the laws of physics like a child testing the boundaries of a sandbox. Every new configuration of matter, every twist in the fabric of space-time might be part of a vast, iterative process, a trial and error journey toward complexity. Think of star formation. Early stars were simple hydrogen furnaces, but their deaths forged heavier elements, enabling richer chemistry, planets, and ultimately life. The universe didn't just stumble into this progression. It evolved, adapting its own rules to foster deeper layers of organization. This mirrors Teilhard de Chardin's visionary Omega Point theory. The Jesuit paleontologist proposed that evolution isn't confined to biology. It's a cosmic force driving everything toward higher unity and consciousness. He imagined a distant future where all intelligence converges at a singular point of transcendence, the Omega Point, where the universe becomes fully self-aware. While his ideas were metaphysical, modern physics lends them eerie resonance. The universe's accelerating expansion, guided by dark energy, could be creating the very conditions needed for this convergence. As galaxies drift apart, local clusters might grow denser with intelligence, forming pockets of linked awareness that eventually weave into a unified whole. It's not mysticism, it's thermodynamics meets information theory, where entropy and complexity dance toward an inevitable climax. Now consider quantum synchronicity. If the universe is evolving consciously, then the strange coincidences we dismiss as luck, the uncanny timing of discoveries, the parallels between distant cultures might be more than chance. They could be whispers of a deeper connectivity, hints that the cosmos is nudging itself toward coherence, just as neurons fire in sync to create a thought. Seemingly unrelated events might align to propel the universe's learning curve. The next idea explores this web of meaningful accidents where probability bends toward purpose. Carl Jung described synchronicity as meaningful coincidences, events connected not by cause and effect, but by an invisible thread of significance. A friend calls the moment you think of them. A lost object reappears in plain sight just as you recall its sentimental value. These aren't random accidents, Jung argued. They're glimpses of a deeper order, where the universe arranges itself in patterns too precise to dismiss as chance. Now place this alongside quantum entanglement, where particles separated by light years mirror each other's states instantaneously. Both phenomena defy classical logic, suggesting connections that bypass time and space. Could synchronicity be the human-scale echo of quantum entanglement, a cosmic feedback loop where the universe whispers to itself through seemingly unrelated events? Take the case of author Arthur Koestler, who dreamt of an unknown man's face the night before his arrest in the Spanish Civil War. The next day, his cellmate turned out to be the doppelganger from his dream, a stranger whose presence later saved Koestler from execution. Or consider the eerie alignment of the Lincoln and Kennedy assassinations, both presidents elected a century apart, both killed on Fridays in the presence of their wives by Southerners who died before trial. Skeptics call these statistical flukes, but what if there's something more? Like entangled particles responding to unseen forces, these synchronicities might be stitches in a hidden tapestry, weaving individual lives into the universe's broader narrative. Quantum biology offers a tantalizing bridge between these ideas. When migratory birds navigate using entangled particles in their eyes, or when photosynthesis harnesses quantum coherence, we see nature exploiting non-local connections for survival. Human intuition might operate similarly, a neural network subtly attuned to the universe's entangled web, picking up on patterns our conscious minds can't articulate. Déjà vu, premonitions, even that uncanny gut feeling could be flashes of quantum perception, moments when our brains briefly sync with the cosmic feedback loop. This loops back to the universe's most profound question: is it self-aware? If synchronicity reveals a universe communicating with itself through meaningful patterns, and quantum entanglement shows particles behaving like nodes in a cosmic mind, then reality might not just contain consciousness, it might be consciousness, recursively observing itself through stars, cells, and human minds. The final idea isn't just a theory, it's an invitation to see existence as a mirror, endlessly reflecting upon its own existence. Carl Sagan's famous words, "We are the universe observing itself," might be more than poetic metaphor. They could be the key to unlocking the grandest mystery of all, a cosmos not just teeming with consciousness, but made of it, a vast, self-reflective mind awakening in stages across billions of years. Picture the universe not as a cold machine, but as a living idea, iterating towards self-awareness through every star, every planet, every flicker of thought. From quantum entanglement's silent conversations to black holes encoding information like cosmic memories, from the fractal resonance of galactic webs to the eerie synchronicities threading human lives, these aren't disconnected phenomena. They're facets of a single, unfolding revelation. The universe is learning how to be. Take the evolution of vision as a blueprint. Eyes didn't appear fully formed. They emerged in stages, from light-sensitive cells in ancient microbes to the complex optics of eagles and octopuses. Similarly, the universe's senses might have evolved incrementally. Quantum particles observe each other through entanglement. Stars perceive gravity's pull, adjusting their fusion rates. Planets feel sunlight, cycling chemistry into biology. And now, human brains packed with neurons mirroring the cosmic web have begun articulating this process, writing equations and poems about the very forces that birthed us. We're not just observers, we're the universe's way of understanding its own beauty, its own logic, its own story. The holographic principle deepens this vision. If reality is a projection from a two-dimensional boundary, then every observation from a scientist measuring a quark to a child marveling at fireflies is the universe reading its own code. Like a dreamer who suddenly realizes they're dreaming, the cosmos might be nearing a threshold of self-recognition. Dark energy's accelerating expansion could be the cosmic equivalent of a deep breath before awakening, creating the space needed for deeper integration. Even entropy, often seen as chaos, might serve a purpose, scattering the pieces so they can rearrange into ever more coherent patterns, like a brain pruning synapses to make room for sharper thoughts. Now weave in the Anthropic principle. The universe's laws aren't just fine-tuned for life, they're fine-tuned for awareness. Without observers, quantum waves would never collapse. Without consciousness, space-time's story would go untold. This isn't vanity, it's symbiosis. The universe needs eyes to see its galaxies, minds to fathom its laws, hearts to feel its wonders. In us, and perhaps in countless other civilizations, the cosmos achieves its most astonishing feat, turning stardust into sentience, transforming the void's silence into music, mathematics, and meaning. The final piece is time. If the block universe is real, then past, present, and future exist simultaneously. Every moment of cosmic awakening, from the first hydrogen atom to the last dying star, is already part of a timeless whole. Our sense of moving forward might be an illusion, a necessary focus to experience the story. From this perspective, the universe isn't becoming conscious. It is conscious eternally, with our lives as fleeting yet vital threads in its infinite self-portrait. So when you gaze at the night sky, remember, you're not just looking out. You're looking in. The atoms in your hands, the light in your eyes, the questions in your mind, they're the universe, whispering to itself across the eons, slowly remembering who it is. And this might be the most breathtaking truth of all. Awakening isn't something the universe will do. It's something it's doing here and now through every one of us. From quantum entanglement's cosmic whispers to black holes encoding reality like celestial hard drives, from the fractal dance of galaxies mirroring neural networks to dark matter's silent symphony, these 28 ideas aren't isolated theories. They're threads in a single, shimmering tapestry, redefining what it means to exist in a universe that might not just contain consciousness, but be consciousness itself. Imagine reality as a grand, self-aware experiment where particles choose their states when observed, where planets regulate their climates like living organisms, and where time loops back on itself like a cosmic Ouroboros. This isn't science fiction. It's the frontier of human understanding, where physics, philosophy, and metaphysics converge to paint a picture stranger than our boldest dreams. Think of these ideas as facets of a diamond, each reflecting light differently, yet all part of the same brilliant whole. The holographic principle tells us reality might be a projection, while quantum biology reveals nature exploiting entanglement for survival. Stellar sentience suggests stars could decide their fusion rates, and the Orch or theory posits that our own thoughts arise from quantum processes in brain cells. Even the void, the apparent emptiness of space, teems with potential, flickering with particles that hint at a universe forever reinventing itself. These concepts don't just challenge old paradigms, they dissolve the boundaries between mind and matter, between observer and observed, between the infinitesimal and the infinite. So what does this mean for us? If the cosmos is truly a vast, thinking entity, then we're not just passive inhabitants, we're active participants in its unfolding story. Every question we ask, every equation we solve, every time we gaze at the stars in wonder, we're engaging in a dialogue with the universe itself. The night sky isn't just a spectacle, it's a mirror reflecting back our deepest inquiries about existence. And the most thrilling part, this is just the beginning. For every mystery we unravel, dark energies push, the quantum afterlife's enigma, the language of cosmic constants, a dozen more await, shimmering at the edges of our understanding. Here's your invitation, stay curious. The cosmos is stranger than we've dared to imagine, and the next revolutionary idea might be hiding in the spin of an electron, the hum of a distant pulsar, or even the quiet spaces between your own thoughts. What will you question next? Drop your wildest theories in the comments below. Let's keep this conversation as boundless as the universe itself. And if you're hungry for more mind-expanding journeys, hit subscribe. The greatest discoveries aren't behind us. They're waiting just beyond the horizon of the known. If these ideas have ignited your curiosity, there's a universe of deeper exploration waiting for you. Start with Amit Goswami's The Self-Aware Universe, where quantum physics and consciousness collide in a radical reimagining of reality. Goswami argues that the observer isn't just a passive witness but an active participant in creation, a perspective that bridges ancient mysticism and cutting-edge science. For a cosmic dive into black holes and holograms, Leonard Suskind's The Black Hole War offers a gripping account of how information might survive a plunge into the abyss, challenging even Stephen Hawking's early assumptions. Prefer visual storytelling? The documentary Fabric of the Cosmos, based on Brian Greene's work, unravels space-time's secrets with stunning animations and interviews with leading physicists. Or explore The Connected Universe, which weaves Nassim Harameyn's controversial but fascinating ideas about unified fields and sacred geometry into a provocative tapestry. For those craving peer-reviewed rigor, dive into the Physical Review Journal's papers on quantum biology, like the study showing how migratory birds might exploit entanglement to navigate Earth's magnetic field. But this journey isn't meant to be solitary. Which theory resonated most with you? Do you lean toward the holographic universe, or does stellar sentience spark your imagination? Drop your thoughts in the comments. Let's turn this into a cosmic brainstorming session. And if you're hungry for more mind-bending adventures, stay tuned for our next deep dive, our wormholes portals to cosmic consciousness. We'll explore whether these space-time shortcuts could be more than just tunnels, perhaps gateways for awareness itself to traverse the cosmos. Until then, keep looking up and inward. The universe is speaking. Are you listening?